Hello, everyone. Welcome to our conversational AI reading group. Today, we are excited to have Michael Hunt from Google DeepMind talking about Gemini voice agent. If you have any question during the talk, please raise your hand or drop them in the chat, and we will go through them during the talk this time. Without any further delay, the stage is all yours.
Thanks, Pune. I'm glad to be here. And Michael, I'm from Gemini post-training team. I work on audio research and also agentic to use. Uh, and today my talk is about Gemini voice agent, a natively multimodal dialogue model with advanced reasoning and tool use capability. Um, and here's the agendas. I would first talk about the background of Gemini, then talk about what is the post-training methodologies we are currently using, and what are the challenges we are facing, and some summaries. Um, so I think since before ChatGPT comes out, every companies have their own voice assistant, like Google Assistant, Siri, Alexa, and it's majorly about the voice command. You have a very short command, like I want to do, I want to know this, I want to play this, I want to buy this, and the natural language processing module is actually very targeted towards those. If you uh, speak something in a different way, then assistant start to glitching. It can't recognize you correctly. And then it also apply for like track the weather, play a game, order coffee. So um, it's a very target domain, which is summarized by probably PM or uh, some engineers collected from lab logs to summarize those intent, and intent classification is error. Um, and we think have a truly multimodal uh, uh, this single model to process all those things is a very key to the AGI. It's prolification of the audio interface in AGI era. The voice assistant companionship in just like character AI and smart devices, you can have the language model play in your small iPhone or Google Pixel, and you have a in-car system also running those. It's I think now the generative models has been fundamentally transforming how um, we understand the world and also machine understand you. It's reason over spoken language pushing us to an interaction. Um, and the brief history of the audio itself is at the very early stage of deep learning, people are actually starting looking at the speech recognition. It's the probably one of the earliest tasks people start to look on, and then some effort like voice AM start to do like TTS, and then people find that it's ready for assistant use case and start to pop up a different assistant. Um, and the pipeline is very cascading. You have to have the text medium in the middle, and this middle part is actually not even large model in early stage. It's a lot of a heuristic and very complex system to process to match that. And you can think of the in the middle every arrows here will provide error and it will make the overall system not very robust. And in the speech to ASR part, you lose a lot of key information like tone and emotion. Uh, Maybe your different tones are meaning different things. That's very common for natural language. And uh, the ASR module itself, if you want to make it very accurate, you're gonna lose those information when you encoding that in the front end. Um, and now we are shifting to this omni model, which can do everything together in a single model. And a lot of companies are looking at it together. And uh, Gemini 2.5 is the first model that we do audio understanding and audio generation together. I think Gemini 1 and Gemini 1.5 already have a very good capability on audio understanding, but now we are adding audio generation to it, and it's trained together with all other team. We share the same backbone model, and uh, a lot of companies in the industry, they have their specialized model for audio, for image, whatever. But the probably they share the same model in pre-training, but the later stage they diverge a lot. But in our Gemini 2.5 is all built in the same model. Um, and meanwhile, we can still keep our audio visual understanding capability to the state of art. We can do ASR transcription, translation, some speech to speech translation, summarization, audio or audio visual question answering to generate sound understanding, music understanding, lyric capturing, and it's not all the things it can do. It's actually a lot of them are emerging capabilities. We don't have time to have all the evals showing in the technical report, uh, but it can do a lot of things that the original legacy system just can't do that. Um, and starting from in the middle of the 1.5 to 2.0, we start to look into the text-to-speech capability. Since you, uh, you can have the text generation, the audio has been seen during pre-training, you start to try to elicit that from post-training stage to see whether the model can speak out those audio directly. And you don't need to for do things like a legacy TTS system. You put a text you want to speak out, and then you need to have other modules to pass. For example, emotion you want to control, the subtle things you want to control to encode that. Usually that thing will make the model confused about the text and your instruction. And if you put it together, sometimes it will read your instruction out. And in a single model, you can actually just basically say that those are the words you want to speak out, and trust the model's instruction following capability. It can do it very well. And we can now support a single speaker speech synthesizer with a highly controllable instruction, and also multi-speaker synthesize. Uh, and right now we use that in Notebook for audio overview. We put into your document, and it will char's URL will be changed to the text format and speak out by the model itself, all in one model. There's some demo here.
Wait a minute. Did you just try to? Oh, that's rich. Outsmart me? Good luck with that one. Ugh, not this again. I really just don't have the energy for it today. Seriously. Oh, thank goodness. I really thought that was it for a second. We're safe.
Yeah, just like the demo showed, it can do like those sign, those laughter, purely by natural language. Is not like fully aligned with the training data at all. A lot of them are actually emerging capabilities, and since the model's audio understanding has reached to the capability that you can actually understand what is laughter, what is sign, And when you do TTS in a reverse order, the model can actually understand the instruction meaning and perform like that.
Well, now, if that fella ain't a bigger spectacle than a pig in a peach orchard, I don't know what is. All hat and no cattle, as they say back home.
This guy here, all show, capiche? The jewels ain't helping his game, just making him look like a mark. A shame, all that glitter, nothing underneath.
Sir, where I come from, substance is usually quieter. This one's hollering like a coyote with his tail caught in a trap every
Yes, so basically this is a multi-speaker TTS demo. We have a single model. You put in the two characters there and set up their voice, and in the script you want them to say just tag which sentence is from which people, and then the model will automatically switch to another people's voice, and that's how no Google Elm is using now, and it's
So Michael, maybe we can do first like round of question, right? So there is actually one already in the chat. I can read it for you. So that's Fabio Catania. Thank you, Michael. This work is great. Quick question. Do the capabilities of the end-to-end model also include speaker diarization, understanding who speaks and when, that will enable multi-user interaction and targeted responses in a group of users?
That's a very good question. So speaker diarization is some capability we are told we can't do in a long time. I think so speaker diarization in industry meaning is that you are understanding users biometric information. So we're not doing it in Gemini 2.5, but recently I think the law has been changed. So this restriction is gradually loosened. So probably in next generation we can start to do that. Now it's more of a we are not telling the model not to do that, and we are not telling model how to do that better. So if the model can do that, then it can do that. But we were not focusing on that in this era, in this version of the model.
Okay, thank you. And we have another question, like the single speaker TTS is nice. How did you incorporate controllable prosody into this model? Forgive me, I'm less informed, less informed, but it seems to be quite hard to get controllable prosody into speech LLM. So yeah, it's about controllability here.
That's a very good question. I think a lot of them are actually coming from the RL stage. We collected a lot of good pairs of prosody, positive and negative pairs, and during RL, the model actually start to correct that behavior. I think after SFT is not as good as this, and after RL is performing very well. It's all the magic from like pre-training. You have the knowledge of what is the natural voice is, and then during RL you direct the model to the right way. I don't know whether that answers this question, but yeah.
Yeah, I think so. So maybe for now we can move on, right? And then we can do other sessions, right, along the way.
Yeah.
Thank you.
In the so basically the TTS model we have in Gemini, you can do dynamic performance like the prosody, the laughter, and those subtle natural response that you can feel like in the real human interaction. It gradually elicits in the generation. and you can have the multi-speaker, and also for multilinguality is gradually transfer from other language alignment to audio, and it can support 24 languages, even if I don't think we actually train with those meta languages, and it's just amazing. And also we have our streaming speech-to-speech translation, which we show some demo in Google I/O, and I think it haven't launched yet, but here's here's some early demo.
Hi, Camilla. Let me turn on speech translation. It's nice to finally talk to you.
Es bueno hablarte finalmente. No puedo esperar a alquilar tu casa.
Te vas a divertir mucho y creo que te va a encantar.
You're going to have a lot of fun, and I think you're going to love visiting the city. The house is in a very nice neighborhood and overlooks the mountains.
That sounds wonderful. Is the house
Eso suena
close to public
maravilloso.
transportation,
¿Es la
or
casa
would you
cercana al
recommend
transporte
renting a car?
público o recomiendas alquilar un coche?
Hay un autobús cerca, pero
There's a
yo
bus
te
nearby,
recomendaría alquilar un
but I
auto
would
para
recommend renting a car so you can visit the nature.
So basically, the demo in this one is showing the model can understand one language and also understand these people's voice, and they can clone these people's voice and to another language, and meanwhile make sure the translation quality is good. And in the middle, there's only very short latency, which is acceptable, but we are also improving that. And the one of the major focus for this talk is about our real-time dialogue model, which we has been working on it nearly a year. And this is an end-to-end model which you speak audio in and speak audio out, and it have a very low latency. It prevent those cues you need to have in the legacy system. It's very natural to do turn taking, and we have a lot of new covers I will introduce later. Human conversation is very rich and nuanced, with the meaning conveyed not just by what is said and what is spoken, and through the tone, accent, and even non-speech vocalizations like laughter. We believe that conversation is a key way to interact with the AI. I think in future, once the audio model has been reaching to a stage, it can be ambient. It's just always on if you want, and whenever you need something, just tell it, then it will handle it for you, just like a real assistant you can imagine. Not like you have to call a certain word to trigger it, and not for a restricted set of tasks. It can do all the things in the same model.
I just landed in Madrid.
Welcome to Madrid. Is everything all right? You sound a little worried. Is there anything I can help you with?
Nah, I'm just tired. What's the weather like today in the city?
It seems like it's currently sunny in Madrid, and the temperature is quite warm, around 88 degrees Fahrenheit. It should be a pleasant day for you. Get some rest when you can.
Can you tell me about the weather again, but with a cowboy accent?
Well, now saddle up, partner. The weather in Madrid today is looking finer than a rodeo. Sun's out shining like a polished badge, and it's hotter than a tin tube roof in July, sitting right around that 88-degree Fahrenheit. Y'all better be ready for a powerful day.
¿Es posible hablar en español?
Sí, por supuesto. Puedo hablar en español. ¿En qué puedo ayudarte?
I'm going to Parque El Retiro and leaving at 5 p.m. from the airport. What's the fastest way to get there?
The fastest way to get from the airport to Parque del Retiro is usually by taxi, which can take around 15 to 20 minutes, depending on traffic. Another quick option is the metro, specifically the Line 8 Lubway, which...
Yeah, so basically this demo is showing some key capabilities we're currently having, like effective dialogue, which detect your emotion and respond in the appropriate emotion to comfort you, to make the conversation more human-like. And another feature is the tool use. This one is showing the Google search, which is our first-party tool. And our API can actually support you to put whatever tool you want to put in. Like people can put it many tool they want, and they build agent around our voice assistant. A lot of startup, their core is actually using our model, and they put different developer instruction and function in it to make their downstream production use cases. And we are collaborating with a lot of them, and they all give us very good feedback. And another feature is the thinking feature. I think not many like competitors in the industry are actually having this feature. Like in voice mode, they can still do thinking, and in the thinking mode, you can actually control how much budget you want to use. For example, you only want to use 20 tokens for thinking, then you can just set it up. It will still improve that in a certain intelligence boost, and you can also save the latency by setting up a correct budget for that. But if you don't set up the budget, the model will think dynamically. Like whenever it's a hard question, it will think a long time. But if it's a very easy question, it probably won't think at all. And in the thinking mode, it can achieve in a lot of aspect, it can achieve similar capabilities as the text model. For example, if you ask a very hard math question, I think in most of cases it should perform nearly as good as the text model. Although I have to admit it was think for a long time, which is not ideal. But as I said, we have the budget. You can control the intelligence level of the model. It all depends on your usage, but we leave that capability there so that you can still do that. I think there's some question.
Yeah, maybe you can do another round of questions, like question regarding the streaming translation, right? So the demo you have shown. With languages in different families, a word order can be widely different. Classical example here is separable verbs in German, where one part goes to the end of the sentence. So I think you need to have like to observe the full sentence before translating everything correctly. How this is handled?
So this part depends on model itself. If it finds the example, you find the language order problem, it have to wait longer, and we'll also show you the longer latency. That's something that I don't think we can really avoid that.
Yeah, but that's actually it's language dependent, right? So do you have like different latency for different languages, or?
Yeah, the model learn by itself when
okay. Okay, that's interesting. So it's not predefined, right? So the model learn internally when it's the right moment to come out with the.
Yes.
Okay. And and I guess you noticed that there are some languages with higher latency than others because of this issue.
That's true.
Interesting. Okay, maybe another question here is like, if I understand correctly, representations for all modalities in Gemini are fundamentally living in the same space, no? Like there is like at some point there is a shared embedding space for text only and audio only input. Is that correct? Which will be why you can get transfer from text modality even if audio is processed in an audio only way. So I think here is like I guess like some point you have like a shared embedding, right, for audio and text.
Yeah, I think in certain, since they are processing in a same model, so you certain stages they will share the close embedding space, but I don't think it will share the exact the same space, since audio is difficult. The information density for audio is very different from text. Sometimes the information density is very dense. Sometimes it's like not too much. So depends on your usage. Sometimes you just want to understand the text content of your speech, and sometimes you want to understand all the details of your speech, like your emotion or your background voice, uh, or your subtle prosody changes. So I don't think it will fall into exact same representation, but in certain stage, I think it will share it. It depends on like a later stage, the model start to figure out like only the content that matters. Maybe it will fall into the same representation.
Okay, that's good. So there are like many questions actually coming up. Maybe you can do only a couple of them,
Yeah.
and then we can move on.
Sure.
So one interesting question is about the data, right? So how the data acquisition is done for speech translation? Is everything synthetically generated, or you do something like seamless, like by mining matching pairs from a very large audio data sets?
I think there are mainly two ways. One is synthetic. Another way is Google will have our own vendor on collecting those data we want. We actually don't use a lot of open data that people use in the academia, and a lot of them is proper data.
Okay, maybe
And
I
you can also tell that in our TTS, the um, the prosody, the naturalness of the voice is actually already pretty good. Even if it's synthetic data, I think it's very high quality now.
Okay, so I have to skip some questions, but I saw there are a couple of questions regarding the emotion, right? So how the emotion is identified and handled, right? So do you have specific data representation for that? Is it learned end to end? So how that is handled?
Uh, it's basically learned end to end, and the first we just test our models emotion understanding, and it's already pretty good. And you just need to align a little bit, then add some samples from that. Uh, I think a lot of them actually coming from TTS stage. We found, for example, you add laughter, the model can do that, and then you just need to tweak a little bit, then you can make a lot of data through that. It's all about if your model can understand that if you do it right, the model can also generate the corresponding thing.
Okay, thank you. I think we can move on, and feel free to ask other questions in the chat.
Yeah, thank you. Uh, oh. Yeah, the demo showed about the real-time dialogue. Its voice naturalness is nearly close to the TTS, but I think the demo is from May or June, which is our very early model. I think now the naturalness has been to another level, and the voice control as well. And our model's instruction following has been like changed so much in the past few months, and I just can't wait to let you guys try our newest model, and yeah, the from the native dialog model to the universal multimodal AI agent, we just chat at the beginning. We need to have other capabilities like those agentic use cases. You need to use tools well. Since if you want to, for example, you want to use our model in a call center, or use it for like medical assistant, it have to have the capability to call certain function or tool to replace human labor in certain aspect. Or if it can only do natural dialogue, it doesn't actually helping in the real life. And so tool use is the number one thing that we are optimizing on. And also memory, it need to understand when to put the things into memory, when to retrieve that, so that they can more of like human instead of every time it's a one-time session. And it need to do personalization. If it's a Gemini, it need to understand what is your context have, like in your Google account. If you ask it to pull up your calendar and look for something in your email, and it need to understand you and do that faster, do that better. And proactive is actually something we care about a lot. So instead of the AI Studio demo we showed is more of a turn-based demo, but it's not actually turn-based. It's just because the UI restriction that we have to make it turn-based, and the target we are having is to make it truly proactive. It basically know how to when to respond to you. When it doesn't have to respond to you, it's just don't respond to you at all. And we also didn't show the image in feature. So actually, our model can support texting, can support audio in, can support image in together, and also can do syncing towards all of those. For example, you just turn on your camera and show it something, and ask to think about some image reasoning task, and it will also respond to you in audio naturally and with a very good quality. Yeah, the most useful voice agent use case is when it can reliably connect to external data and services, like we mentioned, user to access real-time information, book appointments, or complete transactions.
Hey, my package hasn't arrived yet.
Hello, John. I see that you have an order placed on September 17th that is currently shipped. Are you referring to this order or a different one?
Yeah, I haven't received it yet, and I want to check which address it was sent to.
I understand. It looks like your shipping address is 123 Main Street, Anytown, CA 12345. Is that correct? Your order from September 17th was shipped to that address. Would you like me to check the tracking for it?
Actually, it should be a different address. I'm at 123 High Street, London, NW1 A1A in the UK.
Thank you for the correction. I have updated your profile with the new address, 123 High Street, London, NW1 A1A, United Kingdom. It does look like your order from September 17th was shipped to the old address. Since it has already been shipped, we may not be able to redirect it. Would you like me to process a refund or order a new item to be shipped to your new address?
I'd like to process a refund.
The refund has been processed for the order from September 17th. You should receive the refund within 5 to 7 business days. Is there anything else
So this is a agentic voice bot demo, and you can see a lot of the functions are provided to the voice agent, and the function response is actually a JSON format, and it only tell you what field is what content, and the model need to understand code so that it can actually understand the function response, and you can see that the response is, for example, this one that is actually very straightforward for a programmer, but it's not actually very straightforward for like normal human that is not in the computer science industry. But since the model have the strong coding capability, it can actually understand those easily. And also when they call the function and to fill in the right thing into the argument, call the right function, sometimes you need to combine them together, and that shows the our strong capability elicited from combining everything together, and to benefit from the text side, the strong coding capabilities as well. This is our proactive audio capability.
Hey, I'm having some trouble with my phone.
I'm sorry to hear that. What seems to be the problem with your phone?
So it doesn't seem to be connected to the network.
Would you like a cup of tea?
Oh, yeah, please.
Milk and sugar?
Yes, please.
I can help with that. Have you tried
This demo is basically showing someone from other places interrupting the user, and the model will just ignore that intermediate thing and continue to do the task.
Can you help me figure out a good birthday present for my brother? So his birthday is next Friday. He likes hiking, and he's also he's really into photography. Have you got any ideas?
Okay, a few ideas for a hiking.
And this is handling the natural pauses people have.
How may I help you?
Hi, I need to check the status of a recent order.
Certainly. Do you have your 5-digit order number from your confirmation email? Or would you like me?
I have the 5-digit number. It's 45229.
Thank you. Let me check that for you.
And this is the bargain feature. So those are three like major thing that we currently already have. I think there are more of them to have a very natural interaction. And proactive audio is really some feature. I think it'll change the way you turn on the voice assistant. If it can always understand when to respond and when it's not, you can just keep it down as always.
I'm here with the latest research prototype of Project Astra, and we're going to see how it can help me fix my bike. Hey, go online and look for a user's manual for a Huffy mountain bike.
I have found a user manual for you. What would you like to know about it?
Okay, cool. Now scroll until you find the section about the brakes.
Sure thing. Looking for that page now.
I think I stripped this screw. Can you go on YouTube and find a video for how to fix that?
Of course. I'm opening YouTube now. This looks like a good video.
Place a rubber band over the head of the screw.
Oh, nice.
Press down
Thanks.
firmly.
Can you go through my emails with the bike shop and find which size hex nut I need?
Sure. According to the email from Bicycle Habitat, you need a 3/8" hex nut for your sprocket. I've highlighted the correct bin for you.
It seems like I need a spare tension screw. Can you call the nearest bike shop and see what they have in stock?
Yep. Calling them now. I'll get back to you with what they have in stock.
I think my brake pads are wearing down. Can you check the manual again and see if it talks about them anywhere?
According to the manual, if you look on page 24...
Do you want to get lunch?
Yeah, give me 5 minutes. Can you finish what you were saying?
As I was saying, if you look on page 24, section 2, you'll see how to replace the brake pads.
Hey, any updates on that call?
Yep, I just got off with the bike shop. They confirmed they have your tension screw in stock. Would you like me to place a pickup order?
Could you show me some examples of dog baskets I could put on my bike?
Sure, I can help you with that. Just give me a moment. Here are some options. I think Zuka would look really great in these.
This is a compact demo which combine everything together. Just want to display see what I mean, like when you turn it down, always it can do a lot of things for you automatically.
Michael, can I jump in actually, because there are other questions. In general, thank you for sharing the demo, but I think in this reading group, we are more interested in discussing the technological part to the extent you can. In that sense, there are like some questions, for instance, regarding the reinforcement learning stage. For instance, like
I will talk about that later.
oh, you're gonna that because I think there are general questions like for instance, like you said that the this RL stage is able to better capture a prosody, right? Is like they are asking if this is like reinforcement learning from human feedback or like yeah these kind of questions. So you are going to provide later some more details on that.
Yes.
Okay, so we
yes.
can wait for it. Okay, no problem.
Yeah, the next part is about the post-training like methodologies. And due to the confidential policy, I can only talk about limited things, but I will try my best to answer questions. And as we said, the model is altogether is a 2.5 Pro model, and the Flash model is a mixture of expert transformer, and it can have as long as the 1 million token as the context window, and it can input as the text, as the audio and the image, and it can output the text, audio, or image. And basically, it's a very standard, probably 3 stages training. We have the SFT stage. We just have a very high quality data, curated ideal conversations, and to teach the model how to learn certain skills and the steer's behavior align more with the downstream use cases. So we don't put a lot of effort on in the SFT stage. It's majorly to tell the model how to do certain things like with a very small amount of data. And then a more focus would be in RL stage to elicit the model into the right direction. And in the middle, we have the knowledge distillation part. We train a large teacher and smarter teacher and distill that into the student model. And the method have the online distillation or offline distillation. They have the soft distillation, also the hard distillation. Yeah, probably I can stop here for now and answer some question about those 2 parts, or I can also,
Sure.
yeah.
We can do that. Actually, yeah, I'm sorry, there are many questions, so I'm really not able to do all of them. One interesting question is like how Gemini compared to Moshi, right? So Moshi is a kind of an alternative that's was released some time ago. So how would you compare Gemini with Moshi? Probably you say it's better, but yeah, if you can comment a little bit
I think
about
if
that.
you try Moshi and Gemini live model, which is the newest one, probably you can try that in AI Studio. So Gemini live model in your Gemini app is linked to some model we have 5 months ago. So this is a very old model, and it's just pushed to fully online probably this month. So because of some company issue, but we are accelerating that. In future, we will launch that sooner. But since this dialogue model just come out this year, so the process is really slow. After I/O, we only we launch it on Gemini app just this month, and on AI Studio you can try our model. And if you compare with the Moshi together, I think Moshi in general have a very low latency, probably lower than us. But for all other competitors, I think we are pretty fast on latency. But if you're comparing with the intelligence level, I think we are far above Moshi. But that's just my word. You can give it a try and let me know if you have any other feelings, and just please send me email, and would like to get some feedbacks.
Yeah, another related questions like, do you have like a chain of thoughts like in Audio Flamingo internally, or this is not happening in your model?
I don't think I can speak about it.
Mhm.
Yeah.
Okay, no problem. Then another question is like in the demo, how is the agent handling background conversation without explicitly attempting speaker diarization?
It's not the explicitly attempting speaker diarization. It's purely by you just pass all the audio to the model, and the model without any like label of the speakers, it's just automatically do that. It's done in the latent space. It's not done with the explicit label or extra model to do that.
So how many training stages done using supervised fine-tuning, PEFT, LoRa? Maybe each stage focus on different skills, etc., or is typically done in one? So like you're like iterating this, like, or like is everything done is in one stage? That's my understanding of this question.
Yes, when you push everything to the product, there will be multiple stages. And I think that this year we are already simplified that a lot. It's, I would say, very few stages if you compare to last year. So the answer is probably like I can't say it in very detail, but yeah, it's not many stages now.
Okay, so the trend is to reduce the stages. Okay,
yeah.
Clear. Maybe the last question. For Project Astra, do you see agent memory as mainly semantic text content, or it should be able to answer things like, tell me if my audio had noise background in our yesterday's conversation with you? So essentially, like, are you capturing semantic or both? I guess both, but can elaborate more.
Yeah, I think it's both.
Yeah, so the model is like smart enough to capture both the semantic and
yeah. One more question.
I think we should be done. Maybe, yeah, maybe only one. Again, related to Project Astra. When Project Astra suggests product, for example, recommending a dog basket for a bicycle, are those suggestions purely model-driven today? And if commercial recommendation or aids are introduced in the future, how will transparency and user choice be handled? That's maybe a tricky question, but yeah.
Yeah, I actually don't think I have the answer. It's more of a probably PM and the business side of questions. So yeah, I don't think I have the answer for that. Sorry.
Okay, so I think we can move on for now. Thank you.
In the reinforcement learning, so we basically aligned with the verifiable rewards and model-based generative rewards to provide more sophisticated and scalable feedback signals. We use user preferences. If it's not in the product, we will ask vendor to annotate those. And to use execution feedback, you can think of if the tool achieve certain goals, you can pass the right signals for it. And sometimes the model is just behaving stupid and very easy to tell pattern. You just define heuristic rules to correct those as well. And those are probably three major directions, but in reality, it's actually far more complicated than that. And you can imagine the in RO stage when we train the image, text, and audio together, there will be like hundreds of different rewards combining together, and to train one single model. And you have the model-based, several kind of model-based, and many of them are also verifiable. Verifiable now, I think a lot of them is also related to some model for verification. I think one of the capability that we are showing as the previous demo as well is about the reasoning and thinking. So right now we think in those demo, we think in the text space. So basically, it's very similar to text generation. You can check out the thought chain, but the response is all in audio. And we also show that the thinking stage can greatly improve the model's intelligence level. And I think some artificial analysis help us do this comparison with other models. And I think with the thinking on, we can reach a very good speech reasoning capability, even if I don't think we spent a lot of time on this speech reasoning task itself. It's majorly in RL, we try to elicit the reasoning capability to make sure the thought chain is thinking in the right content and in the right way. And then intelligence level will be bring up by the good thought chain quality. And to use, we are trying to enabling the voice agent to call external APIs and tools, and it can be used to call center. And we're also working with a lot of startups on integrating our voice agent to their like actual application use cases. And the design of the complex RL environment, including multi-step actions and tool use, is the key focus we are having now. And some challenges we are having, probably we can also chat about those together, since I know that people are caring more about the technology itself. And intelligence gap is something that a lot of speech-to-speech model is facing. So if you ask the same question in audio and text, and the model, even if it's the same model, will return different content, and the style will be also different. You can think of the text will return you some markdown, some emoji to have a very good presentation of the result, and make you like the result better. But probably in audio, it will have a better response naturalness, and also it will be more like a spoken format, and you will feel okay, you are speaking in very natural and in a very simple words, and you are speaking it very concise, then I will like it more. And so why this will happen? Some potential reason could be the representation gap. As we mentioned that when you encode audio into the embedding, what do you care about? Like, do you care about those nuance, or you care about the emotion? You care about the content? When we build this tokenizer into baking those thoughts, and to think of what your representation should have. If you just purely optimize it towards audio understanding, maybe you should only let the audio representation as close as text representation as possible. If you care about the emotion, care about the prosody, and you want to use that for like a generation, probably you should care about others. And when you do pre-training, how you want to align the audio with the text and image, and for example, if you ask or existing like the current Gemini voice agent model to answer some very hard math question, it can do that. It can do it well in many very hard problem. But do you think we can find such example in the pre-training audio data? I don't think we have a lot of such like hard reasoning math conversation in the world. Even if you can search all the YouTube data, there might be some talk, just like this talk would probably put into the YouTube, but the really amount is very limited, and the depth of those audio is also very limited. It can cover like the human histories, like those books, and the very hard philosophical questions and math questions. So in pre-training, how do you align the audio content and the text content? And that's another part we'll introduce this intelligence gap. And also the post-training alignment part. How do you align the audio response content with the text part content, or how do you tweak the existing thing you have in text to transfer that to audio? Those are all the things we're currently working on. I mean, we already solved some, and we are still solving them. Yeah, probably I can stop here in case people have questions about this.
Actually, let me see. Maybe one clarification regarding the reasoning chain of thoughts. Is that produced in text even if the end output is audio?
Yes.
Okay.
For now, yes.
Okay, that makes sense. So it's not a multimodal chain of thought as in the current at the moment. Yeah.
In the current, yes.
Yeah, but I think a natural extension would be to make it multimodal in maybe in the future.
Yeah.
Okay, maybe another question. As you are combining both audio and text modalities in a single model, for training a pure audio reasoning, do you have a shared network in which you first train on audio to text output reasoning and then move on audio to audio reasoning?
Shared network. All the network is shared together. So
Yeah, there's no distinction, right? It's pure multimodal, natively multimodal. So it's my understanding is that there is no distinction. Okay, I think we can move on. Actually, maybe I have a little question, right? You mentioned verifiable rewards, right? So, and model-based rewards. Like, can you show an example of what is a verifiable reward in that context?
For example, you ask the model how much is 2 plus 2, and then the model should answer 4.
Okay.
This is verifiable.
So you already know the answer, essentially, right? So, okay. Okay. I think we can move on.
Also, the agentic use cases like give us a lot of challenges, combining different tools, and people when they used our AI Studio and Vertex API, they put more than 100 tools, and they put very long context instruction following tasks, like put more than 50 PDF pages of development instruction into the model to let the model follow it from step 1 to step 1000, and it's need a complex multi-step tool use requirement. For example, you ask a very simple multi-step tool use. I always like to resist pull up my email and pull up my tomorrow's calendar and send the email to some people. And you have to call multiple tools and multiple APIs together. And meanwhile, the model need to understand name entities, which is old-fashioned problem for ASR and TTS. But of course, the audio model will always have such kind of issue. And in that process, the model need to do self-correction and self-verification, just like classic Joe's and Jose difference, or like maybe 5 different spelling of Michael, and the model need to do self-correction and self-verification. If it's not pulling up the Michael for this spelling, you need to find another Michael. And if the model is confused whether it should send to this Michael, you need to verify that with the user. And after it's done that, the model need to verify whether it's done, so that it can confirm and reply to you reliably. And sometimes they need to use tools, sometimes it doesn't. Just like you ask a math question, if it can already use tools to solve that, why do we need to think like thousands of tokens for that. And it all depends on whether you provide tools and whether the model can excel that tool well.
Okay. Yeah, maybe we can move on, and then there are few other questions, but maybe we reserve that for the end because we're running out of time.
Yeah, maybe after this page, it's more like that.
Sure.
Yeah. So the other challenge is the multi-objective rewards for speech. Just like the previous slide shows that we have those naturalist rhythm style constraints that we want the model to be very natural, and meanwhile we want it to be very smart. And combining those together and to make trade-off, and that's I would say the thing that spend our 50% of the time on. And we need to balance the latency and the intelligence, and also cover that the streaming translation problem. You don't have a bad translation because the right word haven't come in yet, and you also don't want to let the user wait too long, and the user experience will be very, very bad. And data creation at scale, the syntactic data as quality now I think is reached to a better stage. But how can we in the long run, as the model capabilities grow bigger and bigger, how can we support all the new capabilities easier? Those are something like we want to make everything automatic and don't need to have a human intervention every day. And we also want to develop a better evaluation benchmark for speech-to-speech model. So one difficulty is that we don't have a LM6 for speech models, which I'm really enthusiastic about, to have all the speech-to-speech model talking with each other and talking with the user and let the user choose which one is better. I think it's overall very useful for the audio industry to have that, so that we can understand what are the challenges. A lot of people are looking into audio evaluation benchmarks now, but I think it's still a lot of things you can do in that area. And we would love to see more and more evaluation benchmarks coming out in audio space. Yeah, probably in the interest of time, I will stop here and have some questions. Then we should wrap up.
Yeah, that's great. Thank you for your presentation. Maybe we can do the very last round of questions. There were already many, and I couldn't even read all of them. There are many questions actually related to reinforcement learning, so please reply in the way you are allowed to reply. So, but essentially, people are interested in how reinforcement learning post-training can incorporate prosody, right? So better than, for instance, injecting prosody embeddings. So people ask if you can provide some more details on that part.
There's no prosody embedding used in our model. It's pure like you encode audio and the model understands those prosody by itself. And when you do RL, you can, for example, you can collect human feedbacks on the prosody stuff, and your user prompt could be about prosody. And also you can add some your own rewards to detect those. And the audio research has been grow in last probably 20 or 30 years, and there's a lot of existing tools you can use to detect those. I think that would be the best answer I can give.
Sure. Thank you. So another question is maybe I miss it, but during the intelligence gap slide, it was said that there was a specific work on aligning speech and text modalities. Anything that can be shared about it? What kind of adapters or training strategies are used in that context?
I think I already covered in the previous presentation. So yeah, I think I already covered what I can speak about that. Sorry, maybe Yeah.
Let me find another question, maybe last one.
Yeah.
More general. Let me try this. In a real case where a user speaks quietly with emotion in a noisy environment, how does Gemini decide to trade off between speed and voice quality? And it is and is that mostly end-to-end learning or some extra control layer?
Speed quality.
Trade-off between speed and voice quality. I think yeah.
So the generation side, we won't get affected. The input side, the speed. I think that this question is about the latency in the noisy environment. So I think we are trying to just feed as much audio into the model as possible, and we don't want to have a. So we want to let the model itself to detect what to reply, and we want to have as low latency as possible. And if the model feel is now the right time to answer, the model can answer itself, or it will just yeah, it will just respond.
Okay, maybe last question here is, could you share information about the speech codec tokenizer that you are using for the model? Are they fully acoustic or mixture of semantic acoustic? Can you share some information regarding the tokenizer itself?
Yeah, those are all proprietary tokenizer, not the academia tokenizer. So it's trained in very different ways. Yeah.
So yeah, you have your own internal recipe to train a tokenizer, and that's your okay. So it's not, of course, using any open source tokenizer available. Okay.
Probably we should end up here. Thank you for having the
we are already over time. Thank you very much for your time, and of course, you gave you satisfy our curiosity in the way you could, right? But thank you for that. For the others, let me just welcome you for the next weeks, where we also have great speakers. So let me just see you next week for the next speaker. Thank you very much.